All right, little 5-minute lesson on proving triangles similar. Since we've already experienced proving triangles congruent, and there were, I think, 5 different theorems to prove triangles congruent, there are only 3 ways to prove triangles similar, and we've already gone through this, so this is kind of a quick lesson, okay? The 3 ways to prove triangles similar are angle, angle, and then this little tilde means similarity, side, 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 similarity, and side, angle, side, similarity. Okay? So now I'm going to give them to you. They're pretty simple. If 2 angles from my triangle are congruent to 2 angles from your triangle, then our triangles must be similar. Why do they stop at 2? Caden?
Because since triangles, all the angles add up to 180, if those 2 are the same, that means that all their angles.
So well said. So if you couldn't hear it on the video and you're watching from home, since all triangles have an interior sum of 180, then we could call angle C 180 minus these 2, and we could call angle F 180 minus these 2, but since they are congruent, then they also must be congruent. So essentially, it allows us to save ourselves a step. Does anybody have questions about angle, angle? Make sure you include the little tilde sign. Now, in side, side, side similarity, you are not proving that the sides are congruent because the sides are not necessarily congruent. So take a close look up here. What do we have to do to prove or to use side, side, side in a proof? You have to prove that all 3 corresponding proportions, so a set of fractions, are all congruent. So each ratio gives you the same value, or that all 3 of them are proportionate. Okay? So one of these just involves angles, one of them just involves sides, and then finally the last one is side, angle, side similarity. So if you have, oh, hold on, where did this come from? Oh no, this is the wrong slide. I pasted the wrong one. Let me just, I'll just draw it on here. So for side, angle, side similarity, you might have a scenario like this. Angle B is congruent to angle E. AB is 10. BC is 6. DE is 20. And EF is 12. That's how you would use side, angle, side similarity. So AB over DE is 1/2. BD over EF is 1/2. So you have 2 sides that have equal ratios and the angle included between them. And that's how we would use SAS. Okay, let's look at 2 examples. Here's an easy one, and then we'll do a harder one. Bryce is 6 feet tall and stands tall during the daytime as his shadow casts an 18-inch shadow. At this exact same time, Bryce spots a Yeti, and while he's not able to see him for long, he takes a look at the video from his drone and figures out that the Yeti's shadow was 5 feet. Thank you so much. The question is obviously, how tall was the Yeti? So we can draw a little picture of this scenario. We have Bryson is 6 feet. Now, what do you notice about his shadow? What is it measured in? Inches. We don't want to go feet to inches, so we're going to change 18 inches. How many feet is 18 inches? 1.5 feet. Okay? Now, we know that the Yeti, his shadow is 5, or her shadow is 5 feet long. So now we can set up a proportion. How do we know that these triangles are similar? They both have a right angle. They're both having the sun hit them at the same time, which means those angles are congruent. So we're going to just kind of insinuate AA here. Okay? So you'd say x is to 5 like 6 is to 1.5. And you get 30 equals 1.5 times x. So 30 divided by 1.5. Can somebody help me out with that? Oh, it's 20. So the Yeti is 20 feet tall. Big Yeti. Okay? What are you guys' thoughts on Yetis? Anybody have a thought that they want to share? No thoughts on Yetis. Okay. Anybody have thoughts on Sasquatches?
Neither of them are real.
Okay, so you do have thoughts. Good. All right, now here's a harder example. I'm going to pause it and see if you guys can come up with the right answer as a table. Gigi is standing at 5 feet tall and is standing 15 feet from a 20-foot light pole. And the light pole is shining a light on this situation. We're at night. How long will Gigi's shadow be? This is a harder one. I'll pause it. Go. All right, so the picture is usually easier to set up than the equation. We got a little light pole here. Shining light in all directions. And then we've got Gigi standing here at exactly 5 feet tall. Okay. And then her shadow is over here. That's what we're looking for. The light shines there. And now we just got to kind of fill in the rest of the pictures. We know that these are similar because they have two angles in common, right? How tall is the light pole?
20 feet.
So this is 20. What else do we know?
Like she's standing 50 feet away.
15. All right, is that all we know?
And then she's
All right.
5 feet tall. Oh yeah, she's 5 feet tall.
And she's 5 feet tall. Good. Thank you. So if you draw your triangles out to help you, you have x is the 5. And then what do you have over there? What's this?
15.
No, it's 15 plus x. And what's this? All right, so we got to say 20 is the 5. First of all, you can set up these proportions lots of different ways. 20 is to 5, like 15 plus x is to x. Don't forget to distribute. So you get 20x equals, what's 5 times 15? I think it's 75, right?
Yeah.
Plus what? Plus 5x. That's the part that many people would forget to do. So then subtract 5x, you get 15x is 75. So x is 5. There you go. It turns out that it's a perfect 45, 45, 90 triangle. Right? Because the distance between her and her shadow is 20, and the height is also 20. So her shadow is going to be 5 feet long. Got it? Okay, hope this helps. Get working. I'll keep giving you guys help. I want you done with Unit 7, by the middle of next week, it looks like. Boom.